Okay, so in this video here, we're going to be talking about compound interest, and we have two different formulas that we're going to be using when dealing with compound interest. The first formula that we're going to be using is for straight compound interest, meaning you're going to be compounding it a certain amount of times, and that's going to be n. And the formula that we're going to use is right here, okay? Now, if you have continuous compound interest, that will be the formula below, and that involves E, or Euler's number. Now, I have a whole video on Euler's number, so if you don't know what Euler's number is and where it comes from, go ahead and check that video below. I'll go ahead and link it. That way you have access to that content. But assuming you know what E is, we're going to go ahead and go right along with this video here. And some key takeaways: P is representing your principal amount. That's like your initial amount, the initial amount that you're starting with. R is representing your rate, and that will always be the decimal equivalent of the percentage. So for example, if you have a rate of 50%, when you plug it into your formula, you want to plug it in as 0.5, not 50. T will be time, and that's going to be in years. And N is the number of times compounded per year. That simply means we're going to take our rate and we're going to divide it by a certain number. Now, they may not say that it's compounded at all. And if that's the case, you assume that N will be 1 there, meaning it will be essentially compounded only one time. Right? So N will be 1 in that case if they do not say otherwise. But let's go ahead and take a look at our first example here. So here's our first example, and it says the following. David invested $7,500 into a retirement account with a fixed annual interest rate of 5%, compounded continuously. Now that's your key word right here, continuously. So I already know what formula I'm going to use. That's going to be the continuous compound interest. So that formula is going to be A equal to P times E, all to the power of R times T. From here, all you're doing is simply plugging in these values. It's asking what will be the account balance after 20 years. So when we plug it in, we're going to get A is equal to our principal amount or initial amount. That's going to be $7,500. So $7,500 times E, and again, E is a number, it's about 2.71, but you should have that on your calculator, so you don't have to round it. So I'll have E here, to the power of R. Now my rate here is going to be 5%. When I plug it in, I want to make sure I plug it in as 0.05, not 5. Okay, so I'm going to plug it in as 0.05, that's 5, and then time, that's going to be 20. And then from here, all you're going to do is plug this into your calculator, and you're going to get your answer. So when you plug that into your calculator, you're going to get the following. You get A. So A is equal to, and we get 20,387. And rounding to the nearest cent, we get 11 cents. And there it is. There's our final amount after 20 years. Okay? So that one was dealing with continuous compound interest. Let's go ahead and take a look at another example. So here's our next example. This one says John buys a motorcycle for $22,650. The motorcycle depreciates at a fixed rate of 8% per year. How much will the motorcycle be worth in 20 years? Now, the key word here is depreciates. We're going to be using compound interest, not continuous, because they don't say anywhere in here continuously or continuous. So we're not using continuous compound interest, but we are going to use compound interest, and when we put it in, we're actually going to put in a negative, right? So what I mean by that, if you go back to the original formulas, and I'll go ahead and pull that up right here, you can see that I have plus or minus right here. That doesn't mean we're going to put in both. That means you have to choose, and if it's depreciating, that means we're going to put in the negative, right? Now, if it was going up in value, then we use the positive, but again, it's depreciating, so we're going to use the negative here. So let's go back to that problem. And taking a look at it and setting up our formula, we're going to have A is equal to our principal amount, our initial amount. That's going to be 22,000. So 22,650, right? Times 1 plus my rate, which is going to be 8% per year. Now, when I put that in as 0.08. All over the number of times compounded, well, that's going to be 1 because they don't specify how many times it's going to be compounded. So we assume that N will be 1 here. So N is 1. And then all to the power of N times T. Now N is 1 and T will be 20. And then from here, we're going to plug it into our calculator and we're going to get our answer. And when you do that, you get the following. You get A is going to be 4,273. And rounding to the nearest cent, you get 90 cents. And again, that will be in dollars, right? So that will be the final amount after 20 years. So again, you can see that it is depreciating in value, all right? All right, let's go ahead and try two more examples. So here's our next example, and it's saying Sarah invests $8,900 into a high interest saving account. She receives an interest rate of 9% compounded monthly. Now that's a key word right there. We'll go back to it. What will be her balance after 10 years? So this one, again, you don't hear those words continuous or continuously, meaning we're not going to be dealing with the continuous compound interest formula, but rather we're going to be dealing with just compound interest. So we need to go ahead and figure out what we're going to plug in here. So we're going to have amount A is equal to our principal, our initial amount. That's going to be 8,900. So 8,900 times, here we'll have 1. Now, again, it's going to be appreciating, right? It's not going down in value. You're going to be gaining here. So we're going to use plus, and then 9%. I want to plug that in as 0.09. All over the number of times compounded. Now, they're telling you it's compounded monthly. Now, remember, when you compound something, that's per year. So if you're saying monthly here, well, we know that there's 12 months in a year, meaning n will be 12 here. So I'm going to put 12. And then all to the power of n times t. Well, n will be 12, and my time here will be 10. And then again, we're going to plug this into our calculator, and we're going to get an answer. So when you do plug that in, you get the following. You're going to get A is equal to 21,817. And then rounding to the nearest cent, you get 8 cents. And there it is. There's your final answer, okay? So let's go ahead and try one more example. This time, we're going to be solving for the time, meaning you're going to have a variable exponent. So here's our next example, and we're going to go ahead and take a look at it, and then we'll talk about how we're going to set it up. It says Stacy has $5,500 allocated to an investment paying 7% interest compounded quarterly. How many years will it take for the balance of the account to reach $20,000? Now, again, we have that key word there, compounded quarterly, meaning n will be 4 here, right? So quarterly, that means 4. Again, it's per year, so n will be 4 here. But they're giving us the final amount now. They're giving us A, and they want us to solve for time. So why don't we go ahead and set it up, and then we'll talk about how we're going to solve for that variable. So A here is going to be 20,000. So plugging that in, we get 20,000 equal to my initial amount. That's going to be 5,500, right? And then times 1 plus my rate, 0.07, right? All over n, which will be 4 here. And then I have n times t. So again, n will be 4. And t, right, I don't know what the time is going to be. I'm going to put t here for the variable, so 4t. So from here, you have to think about how are you going to solve this problem. Now, what I would do first, I would go ahead and clean up this part right here, and then we can go ahead and move on. So if you clean that up, you're going to get the following. You get 1.0175. So rewriting it, you get 20,000 equal to 5,500, then times 1.0175, all to the power of 4t, okay? So from here, you have a variable exponent, and whenever you're trying to solve for an exponent that's a variable, you want to go ahead and isolate the base in the exponent. So for example, I need to go ahead and isolate this part right here before I do anything, all right? So to do that, I have to get rid of that 5,500, meaning I have to divide it out. So I'm going to divide both sides by 5,500. And so I'm going to go ahead and rewrite it as 20,000 divided by 5,500 is equal to the following. We get 1.0175 all to the power of 4 times t. So from here, to bring down that variable, because that's what we have to do, I need to essentially take this variable and bring it down to the front. We're actually going to take a logarithm on both sides. By taking a log, you can then utilize the power property. So for example, if you have log and then base and then x to the power of n, I can essentially rewrite that as n log base of x, meaning this exponent right here can come down to the front. That's called the power property of a logarithm, and you may or may not know that, but that's how we're going to solve the problem. So to do that, I have to take a log on both sides. So I'm going to go ahead and scroll down. In doing that, I get log of, and I'm going to rewrite it as 200 over 55, because again, I can cancel out these zeros, right? So I'm going to write it as 200 over 55. It's just easier. And then equal to, now if I take log here, 4t will come down to the front. So 4t, and then times log of 1.0175. So 1.0175. All right. And from here, you just have to solve for t. So now I'm going to divide both sides by this logarithm that I see right here. So going ahead and scrolling down, we're going to go ahead and do that. I'll get log of 200 over 55 divided by log of 1.0175 equal to 4t. Again, I just divided out that logarithm. So from here, we're going to go ahead and plug this into our calculator. We're going to get an answer. And then at the very last step, we're going to divide by 4 and we're going to get t. So I'm going to go ahead and put t is equal to, and plugging that in, we're going to get the following. You end up getting about 74.41 equal to 4t. And then finally, you're going to divide both sides by 4. And when you do that, you get about 18.6. So time is about 18.6. So actually, I'm going to go ahead and rewrite it as time about, because I'm going to round it, 18.6, and that will be years. Okay? And there it is. So it's going to take 18.6 years to reach that amount of $20,000 at that current rate. All right? So that is compound interest. Again, there's two different forms. You can have compound interest or you could have continuous compound interest. But again, you do have two different formulas there, so make sure you are using the correct one. But that's going to do it for this video. I hope that you gained something from it. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.